let's take a look at number 5 from section 5.4. The log scale shows the size of various objects in meters. We're going to estimate the sizes of the objects in scientific notation. And so I have a couple of things labeled that I've labeled the thickness of a fingernail somewhere around here, and you can see on the log scale it would be somewhere between 10 to the negative third. Okay, 10 to the negative third is right there, and 10 to the negative fourth. So we're going to estimate this as 10 to the negative 3.3. I'm just going to do my best to try to figure out where that falls between negative 3 and negative 4. And now I'm going to use my calculator. Okay, so 10 to the negative 3.3 is about 5.01. And then this notation on the calculator, this is scientific notation, and so this is going to mean times 10 to the negative fourth. So about 5.01 times 10 to the negative fourth is how I will rewrite that. Okay, and then another one, the Empire State Building. Okay, if I look, the Empire State Building is the label ESB. This is the height of it. And I look at that, where that dot is located, which looks like it's between 10 to the second and 10 to the third. So I'm going to estimate it as 10. It's kind of a little bit more than halfway over, so 10 to the 2.6. Okay, and then we'll use our calculator. I'm just going to write these as approximately equal to, because we're rounding. Okay, entering this in the calculator, 10 to the 2.6 is about 398.1. Okay, so to rewrite in scientific notation, I'm going to move the decimal to the location right after the first non-zero digit, and so in this case it's after the 3, so 3.981, and then we're going to multiply by a power of 10. So how I determine that power is to decide how many spaces I would have to move it. You know, what would I multiply by to get back to 398? And that's really by 100 or 10 squared, but you can just count how many decimal places this is, which is 2. So about 3.981 times 10 squared meters.